Hello! In this video you will learn what baluns are, why we need them and how do they work. If the world were a simple place, you could just connect the dipole antenna elements to the radio and listen to whatever goes on in the ether. Luckily, life is not that simple and boring, because if you would do that, you would hear just some noise. Let's take a closer look at what really goes on. When the antenna catches some signal, it means it absorbs radio waves from the ether. As the signal has nowhere to go, it accumulates charges at the ends of each element. At the feed point nodes, the center of this antenna, these charges are the signals which we want to get into the radio. The signals at the feed point nodes are in the opposite phase. Such a pair of signals in the opposite phase is called a balanced signal. But the radio expects something else. It connects through a coax. In the coax, the central conductor takes all the signal and the shielding gets nothing. Thus it acts as a zero reference. Such a pair of signals, where one is zero and the other carries all the information, is called an unbalanced signal. So, how should we connect the antenna to the radio? Starting with my unsuccessful example, if we connect both nodes to the coax center, the signals cancel each other out. So, let's connect just one node. Finally, we hear something.
Alpha to Bravo. Bravo, do you read me?
But we can obviously do it better, as now we are wasting half of the antenna's potential. It would be really nice to convert all the signal from the antenna to the radio, to get from the balanced signal to unbalanced one. And that's exactly what the balun does. Let's take a look at two commonly used balun designs, the coax balun and the coil balun. In the coil balun, the nodes are connected to one coil of the transformer in a way that they act in line. This coil then induces current in the other coil of the transformer, which is connected to the radio. In the coax balun, one feed point node is connected to the other by a coax cable. If the cable length is set properly, the signal from the first node is delayed exactly, so that when it arrives to the other node, both signals are in the matching phase. This matched signal from both nodes is then delivered to the radio. To sum up, we have learned two ways how to convert the balanced signal to unbalanced one by balance. I explained to you the principle of the coil balun, also known as transformer balun, and the coax balun. For simplicity, I did not discuss the frequency tolerance of these baluns. I also omitted discussion of impedance matching, a thing closely related to baluns. For more information, see the links in the description of this video. Last but not least, thanks to all good folks who take care of open source software, and thank you for watching.